Okay, next what we're going to do is we're going to eliminate the parameter, but we're going to realize that's not always possible or necessarily easy. Sometimes we need to use trigonometry and trigonometric IDs. Of course, that's what we're doing in this class. So this time I've given you this parametric equation. X equals 3 times the cosine of t, and y equals 2 times the cosine of t. And this is on the parameter from t being from 0 to pi. So what we're going to do here is we're going to eliminate the parameter. Now getting t by itself isn't so obviously easy right now. So what we're going to do is we're going to think of it in another way. We're going to think about one of those Pythagorean identities, and that seems to be one we use a lot, where we had sine squared plus cosine squared equaled 1. Well, we're going to do that here, and we're going to do that by squaring both sides of our equations and then adding. So we're going to take that, and I'm going to write x squared equals 9 cosine squared of t. And then we're going to do the same thing here. We're going to square both sides. And we're going to get y squared equals 4 times the sine squared of t. And then in each of these cases, we're going to divide out this multiplier to the other side. And what that's going to give us here is x squared over 9 equals cosine squared of t. And it's going to give us y squared over 4 equals the sine squared of t. And if we add those two things together, remember we've got two things that are equal, so we can go ahead and add the left sides and add the right sides. Over here we're going to get x squared over 9 plus y squared over 4 equals cosine squared of t plus the sine squared of t. And that's what we were looking to do, because what does the Pythagorean identity tell us this is equal to? Right, it tells us that's equal to 1. And when we've got this, x squared over 9 plus y squared over 4, what shape do we have? Anybody recognize that shape centered at the origin with the plus sign in the middle there? Yes, it's an ellipse. So, writing our parametric equation back as a two-variable coordinate plane equation is not always the easiest thing to do. Sometimes we have to use trigonometry to go there. Now, the other thing that I want to point out here, so let's go ahead and finish graphing this one, right? We could graph the ellipse, but that gives us the whole thing. We've got to realize we're only going from 0 to pi. So let's go ahead and make, really quickly over here, let's make a t, x, y table, right? And for our t, x, y table, since we're going from 0 to pi, let's go ahead and put in 0. Let's do another one. Let's go pi over 2, and then let's get to pi. Okay? So if we plug those in the x value here, we get cosine of 0 squared. Well, the cosine of 0 radians, remember, is 1. 1 squared is 1, and 1 times, let me go back here. We don't need to do the squared one. We just want to find x. So sorry. Cosine of 0 is 1. 1 times 3 is 3. And we've got a 3 right there. The cosine of pi over 2 is 0. So 0 times 3 gives us 0. And then the cosine of pi is negative 1. Negative 1 times 3 gives us negative 3. On the y side here, the sine of 0 is 0 times 2 would be 0. The sine of pi over 2 is 1, and 1 times 2 is 2. And finally, the sine of pi is also 0. 0 times 2 would be 0. So we've now got these ordered pairs that we can go ahead and plot. 3, 0, which would be here. 0, 2, there. And then negative 3, 0, there. So we only have that part of our ellipse. We're going in that direction. They are both solid dot endpoints, and we've now drawn our ellipse. Now, so over here, what you'd have to do is, if you simplified this, you would have to say y, get y by itself, and then you could just leave it as the positive version, and you would have it limited. Otherwise, you'd have to say, gosh, only positive y values. You have to put something like that in there. So the other thing I want to share with you really quickly before we finish this video up is how to go the other direction. Let's imagine we've got a xy coordinate plane equation and we want to write it as a parametric equation. Well, the funny thing is there are infinitely many ways to do that. There are infinitely many possibilities, but there are some easier ways to go. And one of the easiest ways to go is to say that x or y equals the t value, and then your other value, y or x, equals f of t, a function of t. So to give you an example, we've got this equation of this parabola, y equals x squared plus 3. And we're going to give it the domain from -2 to +2. Well, what I'm going to tell you is all we've got to do is say that x equals t. And if x equals t, put it right there, and we now know that y equals t squared plus 3. So that way you don't really have to even come up with a new equation. You're just saying x is the t, and then y is that same function. The best part is, in the domain here, if we're doing domain for x values from -2 to +2, and t is the same thing, our t value restriction is going to be exactly the same. So our t value restriction here, notice brackets, so it is or equal to, is going to be from -2 to +2. That is probably the easiest way to write a regular equation to a parametric equation. Simply say x is the t, and then y equals that function, and replace the x with the t value. And then your domain is the same for your t restrictions. Right on? I hope this helps out, folks. Any questions, talk to me in the video conference, and I hope you're having a good day. See you later. Bye.